sometimes when you have a spacecraft, it can be modeled by a hyperbola. So this just kind of shows an example. As it gets close to the planet, it kind of slingshots it around, and the path is a hyperbola. So the thing about a hyperbola is when you do the distance, it still has a foci. The foci is, well, it has a focus. There's going to be two of them, so it has a focus. And then when you have the distance between any point on the hyperbola, the distance between them is the same ratio, or the length of them. So if you have this right here and this right here, it's going to be a set ratio. Okay, so there's that. The ratio is the eccentricity, which is always bigger than 1, because when we have the focus is going to be out here. So you're going to have this right here is your length C still out to your focus, but this time your length right here is shorter, where on the ellipse the C was closer to the to the center than this is. So when you divide C divided by A, remember from last night's homework, the eccentricity is the C divided by the A. This is always bigger than 1 because the focus is always farther away from the center than the vertex. So you're going to have a focus. We're not really going to find these directrixes, but they are there, just like a focus and a directrix, like the hyperbola, or sorry, the parabola. The main thing we're going to do is we're going to figure out where these asymptotes are, so that when we go to graph it, you start right here, and then you just kind of go up towards where that asymptote is once you figure out where the asymptotes are. It just kind of follows the asymptote out. If you have, it's kind of like how the hyperbola looks. You have an x squared, and you have an a squared, but this time it's going to be a subtract between them. And then you have a y squared and a b squared. That equals 1. And that would give you a graph that looks like this. So you still find the center, which in this one's 0, 0. In the x direction, you still go out a, which is the square root of that number. So you go over a to the left, over a to the right. Underneath the y, you still go up and down b like we did for the ellipse. So up b, down b. But now, since it's a subtract, it's going to be a hyperbola. Now, if it was a plus right there, it would just be draw an ellipse. But it's not, it's a hyperbola. So what you're going to have to do when you graph these is you need to draw a box that goes through all of these points right here. So instead of drawing an ellipse, I've drawn a dashed line because it's really not part of my graph. And then from there, through the corners of the box are going to be your asymptotes. So that's how you find your asymptotes. So you draw the box and then go through the corner of it. Now on this one, it has an x squared first. Well, the graph of it, it kind of looks like an x. On the x direction, you go over, and this is now your vertex, and then you just go up towards that asymptote. And it's how I really do remember it. I just remember if it's x squared first, so it's the positive one, then it kind of looks like an x. But if I were to do one that looked like this, like y squared over a squared minus x squared over b squared equals 1, this one would look just like that. You'd still go, well, almost just like it. This time, whatever's underneath the y is still what you go up and down, so you still go up and down a, and right and left b. This time the a and b, I'm trying to think if they switch them. Doesn't matter. The main thing is that the slope is just rise over run, so your slope is whatever the y over the x part is. And this time when I draw my asymptotes, if it's a y squared first instead of an x squared, the only difference is it's going to start here and go like this instead of like this one where that one goes on the x's. This one would go like that. to me, this kind of looks like a y. I mean, the top of it looks like a y, so I kind of keep that straight in my head. This is the y squared first, and the other one's x squared first. So notice your asymptotes are just straight lines, and I usually just look at it, and I don't even think of the b's and the a's. I just think rise b, run a. So whatever's under the y is how far you rise, square root of it, and then you run that far. And on this one, it's going to be plus 0, because it's y equals mx plus b. So you have the one that goes positive slope, the one that goes negative slope. The foci are going to lie on what's called the transverse axis. So right here, that is the transverse axis, and that's where the foci are. They're somewhere over here and over here. Kind of like when it was a parabola opened up towards the foci. This is doing the same thing here. So this one, this would be the transverse axis, and the foci would be somewhere here and here. Now on an ellipse, instead of a hyperbola, it's going to be c squared, which is the length out to the foci. That equals a squared plus b squared instead of subtract this time. So your c is somewhere out here. Because on the ellipses, the focus, it always opens up towards the focus right here. Or sorry, on the hyperbolas. Now the ellipses, they were here on the inside, because this is a constant sum, but this one's a difference, so they're going to be on there, on the outside of it. Ellipse. The only difference between this and the equation of the ellipse is this one has a minus right here. So that's the only difference. Asymptotes. Because once you draw your corner points of the box, you need to know where you're going out to. If you just put them here and just draw it, you don't know how steep it is. The equation of the asymptotes on this one right here, hold on 1 second right now. This is going to be your point it goes through. So if you do point slope form, where you have y minus y1, m times x minus x1, like we did in your quiz, the point that it goes through is always going to be hk. So this is going to be your h, and that's going to be your k. And then your slope is always going to be rise over run. The slope is always going to be the one underneath the y, which is b in this case, over the one underneath the x. But on this one, just the way they've labeled it, the slope is a is the rise, b is the run on this one. So this one would be opposite. But just look under the y for the rise, look under the x for the run.
So isn't b always underneath the y one?
On this one, and that's why I hate to use a and b. Sometimes I just don't even use them. I just say leave it the same the whole time. In this, they're saying that a is the one that comes underneath the positive one instead of the biggest one.
So your line's going to be a over here, b over there.
Yeah, and I don't memorize which is which. I just say, okay, rise has to do with y, run has to do with x. So this is rise, this is run. On this one, here's the y, this is rise, this is run. So just remember, rise over run is the slope. This one says foci at negative 1, 2, so let's draw that. Negative 1, 2, so there's one of the focus, and then 5, 2. So that's a focus, and that's a focus. And it has vertices at 0, 2, and 4, 2. So this is a vertex, and this is a vertex. Okay, and that's all it's giving us. That's it. And we have to come up with the equation just from that. Where is the center? In between them? 2, 2. Okay. So is this one going to be an x squared first or y squared first? If the vertices are right here. X. So I know it's going to look like this, x minus h over a squared, whoops, not plus. H and the K are. I know what the A is. If I look at my graph, I can find the A. Where is the A? Here's the center. The A is always the distance where? Between the center, vertices. So that's A, so it is 2. So A equals 2. I got my H and my K. I just don't know the B. All I need is the B and then I'm done. But I do have the foci, which this is going to tell me C right there. What is C? 3? Okay, what's the relationship on a hyperbola with the A, B, and C? Yeah, that's this one. A squared plus B squared equals C squared. Yeah. So this is just going to be 9 equals 4 plus B squared. So B squared equals 5. So now you just have to come write down x minus my 8. What is the A? 4, 2 squared, minus y minus my k, 2. And this is b squared underneath here. So b is the square root of 5, but b squared is 5. Equals 1. And then you're done.
It's the square root of x minus 2, right? I mean squared.
Squared,
How'd
yep,
you get
squared.
A again?
A I could see from the center over to the vertex. That was A, so that was just 2. And then I had to find B because I knew what C was. So once I found that C was 3, from here to here is 3, then I used this to find the B.
So
This one has an X first, so would this one be, look like what when you graph it?
this out.
So open sideways. So you come here and then you just come here.
So is
And it comes from the vertices. Make sure you come from the vertices, not the foci. It'd be like right here.
So there's nothing really that you have to do to graph the parts of it.
Yeah, the actual graph is only that red part. You have to do all that other stuff to graph it. So I have to take this one and I have to change it. I don't want it to look like 4x squared minus y squared equals 16. It has to, for one, it has to be equal to 1. How can I get that equal to 1? And remember, you can always flip this one down, or this one just happens to reduce. So this is just x squared over 4 minus y squared over 16 equals 1. The one trick I showed you, if it didn't reduce down, you can always take that 4 and flip it under like that, instead of doing it like this. I mean, this 4 over 16 reduced to 1 over 4, so it was fine. But if it ever doesn't reduce, you can always, to get it on the bottom, just flip it down to the bottom. And that is the same thing as this. Okay, what do you guys think? Oh, that's tiny. Where is the center of this one? 0, 0. So 0, 0 is the center. Okay, how far right and how far left do I go?
0. Over.
Okay, this is 4, so I go 2. Square root of 4. How far up and down do I go?
4.
Square root of 16, 4. And now, draw a box. If that was a plus between them, you would now just draw your ellipse. And now, your asymptotes. So it looks like my slope is 2. So you kind of they on the X or are they on the Y? Yeah, X. X is first, it's the positive one. So I know they're right here. And right here. And now you just draw it out. So make sure when you draw it out, you're just kind of going right here and then follow that out. And the blue part is the answer. Okay, but we got some twist to it because we haven't done much with the asymptote yet. Yeah, it's just like the ellipses so far, right? It really hasn't been that hard. Oh, we haven't labeled the foci in this one, so we need to label the foci. So we got c squared equals a squared plus b squared. So what is my, c is what I want to find. What is a squared and b squared? 4, yeah, 2 squared. Yeah, you did right. So, but this is, you can just, they're already squared out right here, so you can just say 4 plus 16, or 2 squared plus 4 squared. So c squared equals 20. Now where are the foci? Where are the foci? Now that I have the picture of it, where are they? So 4.5 on the x-axis or y?
On the
X. Yeah, remember they always open towards the foci. 4.5. 3, 4, 5. So 4.5 is right there about 2, 3, 4. Okay, so this one would be 0 square root of 20, and this one would be 0 negative square root of 20. So first step on completing the square, you can't have a 4x squared. I have to have a plain x squared. So I can't just divide everything by 4 because I don't have like a fraction right here. So I'm going to factor it out. Because I'm trying to get it to look like this. It's going to look like x minus h squared over a squared minus y minus k squared over b squared equals 1. I want the x's and the y's on one side and I got to complete the square. So I got to make this be a 1 x squared. So what is this right here? Plus 2. And then I'm going to leave a blank. And then I want this to be y squared. So I'm just going to take out that 3. And this one is just y minus 0 squared. This one's kind of nice, but it's just the y coordinate of the vertex is 0, or the center. Okay, so now you got to decide what you're adding. What am I adding to the side to complete the square? 2 divided by 2 squared, yep, 1. But did I add 1? I wondered if this one was going to work. It's not. I'm going to switch something. Okay. Did I add 1 though? If I times this back out, I get 4x squared plus 8x plus 4. This is actually, I added 4 to this side, so I have to add 4. 2 divided by 2 squared. It's always half that number squared. So this ends up being, so far, x plus what squared, if that's a 2? Right? Well, multiplies to 1 and adds to 2. 1. And then this one looks like this. Now this is a problem that I wasn't liking. It's a negative 12. I don't want a negative 12. How am I going to get rid of a negative 12? No, I need it to be a 1.
Divided by negative 12.
Divide by negative 12. So this part actually becomes the positive part, right? Because negative 3 divided by negative 12, positive. So you have y squared is the positive part. So I'm going to write that one first. Y squared over 4. And then this part becomes a negative. Minus x plus 1 squared over 12, not 12, 3. You guys agree that simplified down that way?
Y squared divided by 4 over 4, isn't it?
I switched the order because of when I divided by a negative, it made this one one be the positive one, and I want the positive one first. What were you saying, Marcus?
Well, shouldn't the one on the left with the y be negative because divided by negative?
But it was a negative 3 divided by negative 12. So negative divided by negative is positive.
I mean the x. Oh, okay, never mind.
Oh yeah, I do have a subtract right here.
I saw what you did. My fault.
Okay, yeah, so that negative turned into this negative right here. Okay.
You just flipped it around.
Yeah, I probably should have left it and then flipped it. So we have to graph it and find its asymptote. So what is the center of this one? The y-coordinate of the center is 0. The x-coordinate is -1. So right here is your center. And then in the y direction, how far up do you go? That's a 4. 2 square root of 4, 2, okay. So I go up 2, down 2. How far right and left do I go? This is a 3 right here, so that's going to tell me how far right and left I go. Yeah, 1.75, so is the square root of 3. So it's somewhere right here and right here. Now I draw a box, so let's move that a little bit farther out. So now when I draw my box, and I just need to draw my asymptotes through the corners. Okay, so there's my asymptotes. I need to write the equation of them in a second. So where do I draw my graph now? It's a y squared is the positive part. So the top of the box or the side of the box? Top. So right here's my vertex. And then it just goes. So when you draw it, all it's going to do is it's going to kind of, it's still going to be round right there. Whoops, and then it follows that out. So now the hard part of this one is just make the equation of the asymptotes. Because we have y minus y1, x minus x1. So I can see that these go through this point, -1, 0. That's what I'm plugging in for my x1, y1. But what is the slope of this line? If I go right here, how far up do I rise? I go up 2 over square root of 3. Remember it was like 1.7. So the slope of this one is 2 over the square root of 3. That's kind of ugly. Most of them probably won't be square roots. So then when you write your equation, you just need to plug it in. Y minus my y coordinate. Let's rationalize this denominator. I don't like it. Remember how to rationalize the denominator? Yep, 2 square root of 3 over 3 times by square root of 3, 2 square root of 3 over 3. X minus my x coordinate. And you can just leave it like that. So those are your, oh wait, one of them was a positive slope, one of them was a negative slope, so I do need to do plus or minus right there. Okay, so vertices 3, -6. So I got 3, -6. And 3, 2. So what kind of hyperbola is this going to be? Opening up and down or right and left? Up and down. Okay. Can you find the center? What's right in the middle? -2. You can always just add these and divide by 2. -6 plus 2 is -4. Half of that is 2. So this is my center. Let's write it over here. Center 3, -2. Okay. And now I have the asymptotes. The main thing I care about with the asymptotes is I need to know the slope of them for one. And if it goes through this point right here, I can just graph it from that point if I want. I mean, I can graph them. I can go, this is the slope, this is the y-intercept. But really, I can go up 2 over 1, up 2 over 1, up 2 over 1, right? Isn't that just a slope, 2? And it ends up going through here. Down 2 over 1, down 2 over 1, down 2 over 1. I mean, that really is -8. So I could have went to -8 and did rise over run. Either way, I can either do it that way or through that point. So this is my asymptote right here. And I guess I really don't have to, graph this if I don't want. I just need to figure out what the A and B are. So this other one is going to be, I could go 1, 2, 3, 4, and then do a slope of -2. So it's going here, here, here. Can you guys see where my box is? So I gotta find the top. I have the top and bottom of my box. I need the sides of my box. Can you guys see where it's at? It goes here, and then how far does it go before I go down? This is the corner, right? Doesn't this go through a corner? That's a corner right there. So this is my box right here. Oh, it goes through a corner. It's right there. So I need to know from the center, how far out do I go and how far out do I go? 2. And then this one was how far up? 1, 2, 3, 4. And this one is 4. That gives me all the information I need to do it. If I have the center and 2 and 2 and 4 and 4, now I can write the equation. Right? This one was, we decided going like this if we wanted to graph it. So is it going to be x squared first or y squared first? It's positive. Is the x squared or the y squared the one that's positive? If it looks like this.
Y squared.
The y.
Y squared. So we got y squared minus x squared equals 1. Now I just need the center. We got the center. This is the one that goes with the x. This is the tricky part. You got to remember this goes with the x, so you got to make sure you go over here and put it right here. This goes with the y, so make sure you come here and put it right there. And then the other part that's kind of tricky is the 4. You go up 4 and down 4, so 4 squared goes under which one? The first one or the second one? Yeah, the y, right? The one with the y. And then 2 to the right, 2 to the left, so 2 squared goes under the x. So, I mean, we could write 16 and 4, but there's your answer right there. All right. If you have an equation and it's all written out crazy and you're trying to decide what the heck it is. If you have only 1x squared and 1y squared, 1x squared or 1y squared, it's a parabola, right? Everything else has had x squared and y squared. So out of all these, parabola is the only one that has a equal to 0 or c equal to 0, but not both of them. The rest of them have an x squared and they have a y squared. You guys agree? Parabolas are easy to tell. A circle. On a circle, remember our equation of a circle was like this. But if it looks like this, how are you going to tell if it's a circle? What is going to be true? It all has to do with the A and the C.
So same.
Same.
What makes it a parabola?
A parabola means it only has either an x squared or a y squared, but not both. But if Marcus was right, if you have A equals C, then it's going to be a circle. Because it will go out the same distance. They both have to be positive or they both have to be negative. Okay, an ellipse. What makes it an ellipse?
If one is like greater or smaller.
Okay, so ellipse and hyperbola, A and C. Hyperbola is going to be the easiest to distinguish because what's the difference between A and C? I guess I could say A times C equals a negative number because remember one of them is positive and one of them is negative on a hyperbola. Or you could say One is positive, one is negative. One positive, one negative. That's how you can tell if something's a hyperbola. And an ellipse, any hints on an ellipse? How would you tell? Because if they're the same, it's a circle. If one's positive, one's negative, it's a hyperbola. Okay, if I do A and C, whoops, positive, and A does not equal C, right? Because if A equals C, it's a circle. Or, I guess if they're both negative, then you can divide them both by negative and they both be positive, right? So they have to be the same thing, like A and C, negative, and A does not equal C. Now A could be positive 3 and A could be negative, C could be negative 3 on a hyperbola. It's just going to be a hyperbola that has like a square box is the only thing. Which would be like a circle if it was a plus, but if it's a square box, then it would be hyperbola still if they're one's positive, one's negative. So I want you guys to look at these 4 things right here. It is actually, I believe I have one of each kind. So choose between all of those and choose which one is which. Okay, so I guess the easiest one is the parabola, right? Which one's the parabola?
D.
Parabola. Circle. Oh, I actually didn't have an ellipse, did I? Which one is a circle? B. B. Positive, positive. Circle. Same number. Okay, this one is a 6x squared minus 6y squared. Hyperbola, because they're opposite signs. So you're tempted to say circle, but one's positive and one's negative, it's not. This one is 2x squared minus 5y squared. So also hyperbola. If it would have been a plus, then that would have been an ellipse.